this is like the Bible, folks. It's you've all heard of the American Relay League in the States. Produce an excellent section of books. This is your reference book. They produce a new one every year. Just a new edition every year. Everything you want to know about amateur radio theory, whatever, is in this book. They're about $50. You get one every once in a while. You look through it if you want, but this is your real reference guide about radios, antennas. So if you're really serious and you want to get into it, there's your reference book. You can leave it here. Anybody wants to look through that? Well, yeah, it's just amount of stuff in it.
For my advanced exam, that was my manual.
Yeah.
Ready for cover to
I
cover.
think they go for about $50, but I buy one every couple of years just to see if there's anything new on them. But there's a good reference point. Okay, now one point I'll use this diagram here to think. So I'm going through the. This is how I check myself to see if I've covered what I'm supposed to cover. Okay. Back to our CW radio. One of the reasons I said, like, we generally don't key the master oscillator. You want it running all the time. You want it stable. You need a good power supply. Because there's a term they call is chirp. In other words, it's like at home when your fridge comes on or something. You know, your lights dim a little bit, so your power supply is shaking a little bit. Well, what would happen here in any CW radio? For some reason, when you key it, the frequency may shift a little bit, because if the power supply can't handle that surge or whatever, you'll find the frequency will shift a little bit. That's called chirp. Actually, I guess you'd hear the sound. It would kind of, you know, like a little bit of a higher pitch perch or whatever. You'll find the frequency. Okay, well there you go. So, in the exam, a couple of questions in the data bank, I actually refer to that. It says, see, they'll ask the same question maybe 6 different ways. So there's 6 possible questions that could pop up on some topics. Really asking the same question, just ask it a different way. So in this case, a small change in a transmitter's frequency each time it's keyed is called, chirp. And the solution, another one here, what can be done to keep a CW transmitter from chirping? Well, the correct answer of a bunch of choices, add little filters. Anyway, it says keep the power supply voltages very steady under the transmit load. So you need a good regulated power supply so that basically this guy doesn't change frequency as you load the circuit down. So, like I say, there's typical questions from the exam. I'll leave this diagram up here because next question, it says, what circuit has a variable frequency oscillator connected to a buffer driver and a power amplifier? Master oscillator, buffer, power amplifier. Unique answer, CW transmitter. Type of modulation changes the amplitude of an RF wave for the purpose of conveying information. Keyword, amplitude. AM, amplitude modulation. And again, see, they ask the same question in a different way, just different language. In a wood emission type, does the instantaneous amplitude, or in brackets, envelope of the RF signal vary in accordance with the modulating audio? AM, So they've asked the same, they can ask you the same question multiple different ways. Morse code is usually transmitted by radio as a series of key clicks, continuous carrier, a voice modulated carrier, or an interrupted carrier. Well, the choice is interrupted carrier because it's on and off as we transmit our characters. And a mismatched antenna or transmission line will present incorrect load to the transmitter. The result will be a bunch of silly questions, and the answer is full power will not be transferred to the antenna because, like in electric, there's what they call the maximum power theory. In other words, it states that maximum power is transferred when the source impedance is equal to the load impedance. That applies to anything in electrical electronics. Slight mismatch between the amplifier and the antenna results reduced antenna radiation. RF oscillators should be electrically and mechanically stable. This is ensure that follow the best choice there so it doesn't drift in frequency. Okay, here's a question maybe I didn't cover well enough, but it's saying, talking about DC power. So it's saying the input power to the final stage of your transmitter is 200 watts, so that'd be DC, and the output is 125 watts, that would be RF. What happened to the rest of that power? Well, it just didn't dissipate. So basically the answer is it's been dissipated as heat loss. During an electrical circuit, when you have more going in than comes out, it's got to go somewhere, so you generate, it just goes as heat. And let's see some of these other things we'll go through. Usual bandwidth of a single sideband amateur signal between 2 and 3 kilohertz. I can mention that. Purpose of a balanced modulator in a single sideband transmitter is to suppress the carrier, pass on the 2 sidebands. Remember, that was the balanced modulator. It was the stage after that we filter out one of the sidebands. Didn't mention it, but they didn't show it in the diagram. Question here, there's, I think maybe that's from operating procedure, but in a single sideband transmitter, the device that controls the level, there is called the automatic level control, which is normally shortened to the ALC. That controls your peak audio, basically clamps or limits so that you can't overdrive your signal. Now remember I said a couple of questions that you should make note of. It says, what may happen if an FM transmitter is operated with the microphone gain or the deviation control set too high? Best answer is it may cause the interference to other stations operating near its frequency. Remember I mentioned that one as one of the points to remember. And again, another question, they basically ask you the same thing on a little bit different words. What can you do if you're told your FM radio is over deviating? Talk further away from the microphone. That's an easy way of reducing your audio modulating signal a bit. Well, here's it good. It says, what kind of emission would your FM transmitter produce if its microphone failed to work? And its best answer is non-modulated carrier. All you would do is you turn on and you just get just a pure carrier with no intelligence on it. So a lot of stuff is just practical stuff. They're saying, what I said you need to know is how to operate so that you're not causing problems to anybody else. You're transmitting FM on the 2-meter band. Several stations advise you that your transmission is loud and distorted. And it says quick check. Frequency says you're on frequency. So now, what's the problem? I think I mentioned that point. The frequency deviation of your transmitter is set too high. So in other words, you're trying to deviate that signal more than you're allowed to. So you're causing interference to others. And some of the questions, you just have to look and read. Some of the choices are so ridiculous that it's pretty obvious. It says, where would you connect a microphone for voice operation? To the antenna switch? To the antenna? Or to the power supply? Or to the transceiver?
Alright, that one's a gimme.
Yeah, so I mean,
Not all that.
it's the key to this exam, if I can tell you nothing else, is read the questions carefully, because the way they word things can throw you off. When you agree that's the best advice, read them very carefully, because sometimes the wording can throw you off. It's not always really super clear what they want.
Do you have enough time to look at all the answers and try and understand in your mind why the other 3 are wrong? Then you'll see how they try to trick.
Okay, and another couple of questions here. They're based on the 1.m. The switching system enable the use of one antenna for a transmitter and receiver. Should also, the choice is switch between meters, disconnect the antenna tuner, ground the antenna. Best answer is disable the unit not being received, or not being used, sorry. So if you're transmitting, disable the receiver. If you're receiving, disable the transmitter. No, that's pretty straightforward. These are actually the questions right out of the question bank. I just, because they're kind of is all grouped together, so I just scanned through it, and when I got into, it looked like the questions all on our topic, I just copied a few pages. And likewise, unfortunately, like I said, you have to know these block diagrams. No way around it, because there's lots of questions here. I can give you, it's what, 5 pages worth of, and all they're just simply asking you the blocks. It says, here's an interfrequency modulation transmitter. The input to the speech amplifier is connected to the microphone. And interfrequency modulation transmitter, the blank is between the speech amplifier and the oscillator. Correct answer is the modulator. In an FM transmitter, the blank is located between the modulator and the frequency multiplier. The answer is the oscillator, and on we go. And there we go. CW transmitter, blank is connected between the driver / buffer stage and the antenna. Correct is power amplifier. That's what I said, kind of in your head. One of it may help you with some of these questions. Basically, like I said, every signal that's going in or out of a radio, it's going to have some sort of an amplifier. Our audio signal coming in is amplified. The signal going out to the antenna, amplified. So, that's maybe one thing that might help you when they ask some of the questions. When they ask about amplifier, the amplifier is the stage, in all cases, that basically relates to the outside of the radio. Again, there's a whole bunch of questions. Unfortunately, they're all like fill in the blank. It's all the blank stage is between this and that.
Just memorize those block diagrams.
That's all I can say. Is unfortunately you have to know those block diagrams.
Take note of the differences. Not hard.
Anyway, that's about all my part tonight. So, questions, or is it clear enough for everybody, or anything I can clarify, or? Well, there's going to be a set of block diagrams for the receivers, and we're going to talk about those on Thursday night. I'll be back again.
My apologies.
Unfortunately, I mean, that's the exam, and all I can do is hopefully make sure that you have an understanding of what all the blocks do, and that's all they're asking you to do, is just to know the purpose of each block, what they do.
Sorry, thinking about the receiver thing again. I'm assuming that there is a difference between transmitting and receiving, right?
Yeah. Well, if you want to jump ahead, you go in the next chapter of the book. All the diagrams are there, but in the next chapter, it's all receivers, and it's going to be very similar. The diagrams are going to be somewhat similar, just that we have to do things a little bit differently.
There's no mic. Oh.
Yeah. There's an audio amplifier because at the end you want to hear what's going to happen. Yeah. It's a power amplifier, you need an audio.
Oh, and I have a question for you. And one of your questions there you had no meters versus frequency bands and how to convert.
Yes.
What do you mean by that?
There's a formula for that. Simple formula.
What is it?
Was it
I'm not trying to test you.
468. It's getting there, isn't it? 468 over frequency megahertz?
No. 468.
I think it's 468 over frequency megahertz.
Well, that's for if you want it in feet.
Yeah.
If you want it in meters, it's basically.
Or just a conversion, or Or
It's a
is
simple
that,
formula to memorize.
is that depending on which frequency you're on, right?
Yeah.
If you're below, I forget what that frequency is, then,
Oh yeah, I forget that topic. I
Yeah,
guess
yeah,
they're
yeah,
for
yeah.
actual practical antenna lengths. I think you change the formula. There's like
Slightly, yeah.
there's
Yeah.
some I forget
Yeah,
what the
there-
cutoff point
yeah.
is, but you change the
so
formula
that's what you
slightly.
mean by that.
It'll be in your book
Yeah.
there, there's a formula.
It's in here,
It's in
yeah.
there.
I didn't know what you meant by
Right
that.
here. There
No,
it is.
no, that's not what you mean.
Wavelength
You
is
wanna
equal
use the one that's
to
meters, because all Canadian stuff is in meters now, I don't think I'm gonna ask
V
you.
over
Constant.
yeah, C over frequency.
But that's, no, that's not what he's, that's not what I was asking anyway.
Okay, that's not quite right.
Yeah, and you also will find that your calculations may not exactly match the answer, but if they're really close, that's the answer.
So this is the different frequency, I think it's at 300 to 280. So we like,
Slight variations.
yeah, this is slight variation, okay, if I remember. Yeah, that's over.
I think I know where you mean now, and I think I remember seeing that formula.
Might be using the wrong afterward, but,
Might have been in antennas.
Well, we still got a little bit of time to kill. Any more questions? And then we can clear up. Or?
Here, right?
They got the meters and.
Get one from Europe, English, go to the English website.
Yeah, I know that one, but there's this,
They didn't have a copy of the